All right, so let's take a look. Let's just say I have a normal distribution like so. In the middle is 0. Now this is 0.94, which is positive, right? So I know it's going to be on the right-hand side. So that should be somewhere like here. All right. And I want the area to the right of it. All right. So remember, in my table, I can't look up areas to the right. I can only look up less than, right? So what am I going to do to get this answer? Take the whole distribution. Take the whole distribution and subtract out the part that you can look up. Right? And then you're left with the part that you actually want. Right? So let's do this. So what is 0.94 when you look it up in the table? What is it? 8 what? 8264. Good. Now we just do a little calculator, 1 minus that, and we Gucci. You know? So let's look. 1 minus. So I got 0.1736. And that's it. Questions on this?
From where she got the one 0.882. From where? From the chapter, what chapter? What page do you?
The normal distribution.
Oh, can we resolve this in the calculator?
Yes. Go ahead. You can do it in the calculator.
Yeah.
But remember, if you do this in the calculator, you have to draw the distribution like we did up here, right? Pretend that you're standing in the distribution, right? You're standing in a distribution. To your left, this is your lower bound. And to your right, this is your upper bound, right? Which we know is going to be, all right, 1E99. And that's it. Then you just do the normal CDF and you get to
To
go.
left is minus 199.
What is that, like, you upper bound,
Mm-hmm.
1E99?
Mm-hmm. So always, right? You stand in the distribution, whatever's to your left is your lower bound, right is upper bound.
That is gonna be in the final. No.
Mm-hmm. It will be. Go ahead, try it in the calculator if you want.
So it'll be parentheses, right?
Mm-hmm. For well,
0.94.
0.94. Yeah,
Oh,
comma. The upper bound. which is 1E99. That's the blue EE. So you're gonna press second and then EE. Or in your case, I guess it's yellow. EE.
Oh. The second and then the E, right?
Mm-hmm.
99. And then pound.
Then your mean is 0, your standard deviation is 1. You got the answer?
Yeah, I got 173.
Perfect. Perfect. Any questions? Hmm.
Percent?
So like
But I got the right answer.
that's the right answer, but like this is how you do it. So second distribution normal CDF. Your lower bound
I
is
did it like this, I
zero
just,
point nine four, comma, your upper bound is 1, and then you see the double E per second, E99.
oh, I pressed,
Yeah. I understand what you did, times cap.
I pressed this.
Yeah, no, it's this one, EE,
Mhm.
right? And then your mean is 0, comma, your standard deviation is 1. Then you get that.
Mm. Well, that's the same answer. No?
Mhm. You got lucky though. Yeah. All right. So let's look at this question. So the probability of Z greater than or equal to 1.15 refers to the probability that Z values lie on the right of 1.15. This is shade the corresponding area under the standard normal curve. This is the standard normal curve here, right? And you're just going to shade everything to the right of that. So you're going to look up 1.15, subtract it from 1, and you get the 0.1251. And that's how you do it when it's greater than. Questions on this? If it was less than, just copy whatever's on the table and you're done. But if it's greater than, you do 1 minus. Good? All right, let's look at B. B says find the probability of negative 1.78 less than or equal to Z less than or equal to 0.35. Then it says first sketch the area under the standard normal curve, right? So you find the negative 1.78 on the table, you find the 0.35 on the table, you subtract the big number from the little number, and that's how you get the answer to this. Questions? All right. So that's it plugged in. Everything nice. The big number minus the small number all the time. Let's see. So here's the next thing that we want to talk about. Areas under any normal curve. So normal distribution areas in many applied situations, the original normal curve is not the standard normal curve. Generally speaking, there will not be a table of areas available for ordinary normal curve. This does not mean that we cannot find the probability that a measurement x will fall into an interval from A to B. What we must do is convert the original measurements from of x, A, and B and Z to Z values, right? So we got to convert our numbers. Here's how we convert. So how to work with normal distributions. To find the area and probabilities for a random variable x that follows a normal distribution with mean mu and standard deviation sigma, convert the x values to z values using a formula. Z equals x minus mu over sigma. Good news, you don't have to memorize it. It's on your formula sheet. Let's take a look. So if you're on your formula sheet, go down towards this chapter 7. I'm talking about the standard score formula. Okay. Hey, when you're done looking at, try this. Mhm. Right. The X bar is your sample mean. Your mu is your population standard deviation. Mu. And like that mu, yeah, was from this thing over. So that's the population mean. It'd be in the question.
So how are we finding the
So just answer it fully. You know, you want the probability of it, the big minus the small, and that's it. Let's try it out. You got this.
That is the population.
Uh-huh.
So is this? So, like, what work would have been,
First one.
standard work? So that tax would be, and to.
Why?
Dollars.
Mhm. That's good. Now plug in the value for X, which is the 11 and the 14.
I don't know how to do this.
Just plug it in the calculator. Yeah. And look it up in a table and whatever is the smallest, wins. $11 minus 10, right? Yeah. X minus the mean divided by the standard deviation. Exactly. All right, we good? So remember now, we want the probability of 11 less than or equal to X less than or equal to 14. Remember, we can't do that. So you want to do the big number minus a small number. So this is going to become the probability of, we can't do in between, but we could do less than and less than, subtract them. So you want to take the probability of, so now, right? Hold on. Now we have to convert this. This becomes probability of Z less than, plug in the numbers. Now just do a little math. First one is 2.00. Okay. So draw your distribution. I want this area in the middle. 0.5 and 2.0. If you do it in the calculator, imagine that you're standing in a distribution. If you're doing it by hand, just look up the two answers and subtract them. All right, let's look at 2.0. You couldn't find 2.0? 2.0 with the zero is a 90, is 97.72. Uh-huh. The big one, my small one. Um, mhm. Let's look it up. Go to 0.5. So 0.6912. Know what you got? It's probably right. That's what you got, Carmen? 2870? So what did we do wrong? What about the 9770 or the 6912? All I did was copy from the formula sheet for those. Didn't make it up. Oh, shoot. I'm over here talking. I didn't even realize I'm not showing you what I'm talking about. My fault. So I plugged in the numbers 2.0, 0.5, looked it up, boom. Right?
So you can just subtract the volumes, not to find
The probabilities. That's what you subtract. Mhm. It's a Thursday schedule. It's regular.
Because they
Yeah.
they just add another extra class, right, for this semester,
I don't know. They
How they
always do
call it?
this transfer days.
like a transfer day. It's
Yeah.
only one day for each semester.
Nah, sometimes it's multiple days.
Really?
Yeah, sometimes they'll switch
For
it
this
around.
semester, it's only 2 days, right?
We had it. We had some more before, didn't we? This year? Or am I bugging? Hmm. And it's only today. But you can always look it up on the calendar when what's going on.
It's how they call
Uh, they just say on this day, Tuesday, Thursday schedule or whatever, or Friday schedule. Yeah, I don't know. The calendar
it.
is
Very
interesting.
confused.
Yeah, the calendar is very interesting. They planned this out like more than a year ago. You know, we just follow it. We good? All right. Does anybody need to see this in the calculator or we can move on?
Put it on the calculator to see how you.
Okay. Yeah. Sick. She didn't feel well. Yeah. But it's all good though. Gave us time to practice more problems, you know? All right. Uh-huh.
A number, and then we can graph it.
You don't have to graph it, it's an option. If you're using a calculator, you have to. But if you're not using a calculator, it doesn't matter. Right? So again, you're standing in the distribution. To your left is your lower bound, and to your right is your upper bound.
Press PDF or PDF?
No, we didn't do that yet. No, I was just talking about the drawing, right? But for this, you will go to distribution. If you're on the 36X Pro, right, you're gonna go second and then stat, then the data, then you're gonna go across the distribution, then you go down to normal CDF.
Or more,
PDF.
Yeah,
sometimes PDF too, right?
never.
It never PDF?
Never. Yeah.
Oh,
So lower bound, upper bounds, the mean, and the standard deviation.
when it's left, it's negative 1 E99. When it's right, it's positive 1 E99. And
Right.
it's
If it's in between, it's the left and the right.
it depends when it's less than, equal, or greater than,
Equal, right?
yeah. So, and it should be on the upper, the number, or in the,
When it's in between,
no, the 1 E99, when it's negative.
well, oh, when it's negative,
It's in the upper or it's in
it would be in the lower bound.
the lower,
Yeah, if it was if it was to the left, yeah,
and the number is gonna be in the,
yeah.
it's difficult.
If the 1E99 was in the upper, um, that's the question that's greater than. Yeah, that's how that would work.
And then if it's like greater than the results, you have to put 1 minus the results.
And that's it. But not if you do it in the calculator.
It's
If you do it in the calculator, whatever the calculator gives you, you're good.
It is, yeah,
Yeah.
yeah, it's true.
Yeah. So for
Give me a little information.
I got you. So look, you go second distribution, go down to normal CDF. Lower bound here is 0.5. Upper bound 2.00. Your mean is always 0. Your standard deviation always 1. Paste. And then you get the answer, right?
Thing always has to be positive, never negative.
Depends on the question.
Oh, it depends the question.
Yeah. All right. This convention, you have to memorize, Carmen, this part, because your calculator doesn't have the GUI though to do it for you. It doesn't have the interface that mine has, right? Like you see when I do, I'll do it again. You see when I do second distribution and I go to normal CDF and I hit enter, this you don't have. Yeah, so you have to memorize this first line up here.
Okay, that's the number.
Right.
That is,
With the commas and everything.
You know what?
so it's 0.5. 2.0.
Right. Exactly.
Zero,
Mhm. Perfect. That's it.
You know what is difficult to find the areas in your assignments? I
The
will do
area-
areas to
this
find
is the area.
probabilities.
This is the area.
This,
Yeah, this is the
oh,
area.
really?
Yeah,
Oh,
yeah.
but he told me we cannot do areas in the calculator. In your assignment, no.
Who
In
said
your
that?
assignment. My tutor,
This is the
he's
area.
a good tutor. So, but he told me I cannot, in your assignment, we cannot do it in their calculator. No. It's something like we cannot do.
This is
We
doing it in
have
the
to.
calculator.
Huh? I don't want to say my tutor. I don't like he's my favorite tutor. Yeah,
Hmm.
he's good.
It's probably Will. Yeah. Or Franklin. One of the two.
I will tell you.
It's okay. Yeah. All right. So enough of all that. I think we get the idea. Let's jump to a new topic. And yes, you can do this in the calculator.
And what? And yet we can do that in the
Yeah.
calculator?
Mm-hmm.
Normal distribution.
So this is called inverse. Huh? It's in your calculator. I'll show you where. Yeah. So inverse normal distribution. Sometimes we need to find the z or the x value that correspond to a given area under the normal curve, right? This situation arises when we want to specify a guaranteed period such that a given percentage of the total products, right, produced by a company last at least as long as the duration of the guarantee period. In such cases, we use the standard normal distribution table in reverse, right? We look up an area inside the table, and then we find the z value on the outside corresponding to it, right? So we are using the inverse normal probability distribution. Let's look at an example together. All right. So we're looking for X given the probability. So Magic Video Games Inc. sells an expensive video game package because the package is so expensive. The company wants to advertise an impressive guarantee for the life expectancy of its computer control system. The guarantee policy will refund the full purchase price if the control system fails during the guarantee period. The research department has done tests that show that the mean life for a computer is only 30 months, right? With the standard deviation of 4 months. All right. That's kind of important. Hold on. The mean life, 30 months. Standard deviation, 4 months. The computer life is normally distributed, right? So, how long can the guarantee period be if the management does not want to refund purchase prices on more than 7% of the Magic video packages, right? More than 7%. All right, y'all got to help me out here. More than 7%. So, where am I going to draw this? Is it on the right side or the left side? No guesses? All right, here. No, it's on the left, right? Right? The reason why it's on the left is because I'm looking at failure, right? When is the video game system gonna break? Yeah, I want to know when the video game system is gonna break, right? But I don't want to pay out 100% of my money that I made on all the machines, right? I want a cutoff period at 7%, right? Here's my question, right? Here's my question. You know your mean is 30, right? How many months is the 7%? I'm looking for something called the raw value here, right? And that's what we have to figure out, all right? Now I know you all know how to do this, all right? So I'm just gonna fly through this real quick. Let's take the z score that we have, right? This is x minus mu over sigma, all right? What I'm trying to say is I don't know what x is, but I can figure out the rest, right? So let's solve for x. So I'm gonna multiply this by sigma. I do to one side, do to the other. So now I have z sigma is equal to the mean minus, I mean x minus the mean mu, then add mu. So we get x is equal to mu plus z sigma. This is your raw score formula. Now, if you don't want to go through all of that, right? This is just solving literal equations, right? You can check out your formula sheet, right? Now, on your formula sheet, right? Your raw score is right here, chapter 7. After that, you kind of just plug in the numbers, get the answer. That's the end of the whole conversation for this. All right. Go down. Hold on one second. Let me see. So I know what my mean is. I know what my standard deviation is. Just plug it in. Keep it simple. Here's the problem. I don't know what the z is, but I can find the z, right? So to find the z, I'm looking for 7%, also written as 0.0700. Questions about this? Good so far? All right. Let's look at the formula sheet. I'm looking for 0700. So I'm on the formula sheet. All right. And then find me 0700 in this. I'm asking, when I say 0700, I mean in the middle right here. That's what I want. 0700 from these numbers. And then you can send them up. Well, I mean, you're done. All right, 0700. Where are you? Scooby Dooby Doo, where are you? Got some work to do now. All right, so I found it. So 0700 is between these two numbers right here. I have 0708 and I have 0.0694. Here's my question, right? I'm looking for 0700. Which one of these two numbers is closer to 0700? Which one would you say? Exactly, right? Because 0694 is only 6 units away from 0700, but 0708 is actually 8 units from 100. So here's my question. We just justified that we're going to use 0694. What's the Z value that corresponds to 0694? Good. 1.4 what? Negative 1.4. No, negative 1.4. What's the number above? No, the number on top in the Z. At the top of the column, what is it? Yeah. Look at the top of it. What's on top? Mhm. What's on top? Like when you look at the top, all the way to the top, what is it?
Negative one.
You're right. That's part of it. But what's the hundredth place? Just look straight up. Look, you're right here, right?
Negative.
Up. That's fine. No, no, no. So go to the where the number is.
Oh, okay, so,
That that's what I'm looking for, right? So negative 1.48, right? So very simply, this is negative 1.48. A little bit of math, boom, 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 and then we'll figure out what this X value really is over here. And that's it. 24 months and a couple of weeks. 24.08. And that's it. Questions on this? So we're given the mean, we're given the standard deviation. We just have to figure out the Z accordingly from the question, and then that's it. Now, I know Danny about to ask this, right? How we do this in a calculator, right?
Yeah, yeah. What is that term?
Inverse normal
Yeah.
distribution. My fault. Excuse me. That was from a previous problem. All right. Anyway, let's say you want to do this in a calculator, right? You press second distribution, and you go down to where it says inverse normal. right? Then you're gonna hit enter. And then what's our area? It was 7%, right? So that's what? 7 divided by 100, something like that. Our mean we know is 30. And our standard deviation we knew was 4. It's on the left. Go down to paste. Same answer. So, right, my fault. So for you, right?
So it's second data and then inverse norms,
Yeah.
and then just.
So inverse norm,
Yeah, better.
right? So the first thing you're gonna do is you want your area, then you want your mean, and then you want your standard deviation sigma. I'm sorry. Right? And then after that, you want to say where your area is to the left or to the right? Right. Oh yeah, commas. That's important too. Remember your commas. Yeah. 7 divided by 100, 7%. Because we're remember we're working with this question over here. Mm-hmm. Mm-hmm. Well, no, the negative comes by itself. You don't have to worry about that. The area is 7/100. The mean is 30. The standard deviation is 0.4. Just plug it in, click, 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 and you're done. All right, I think we'll wrap it up for that today. Please sign in though before you leave. All right. I will see y'all tomorrow. Tomorrow's a regular Wednesday. I don't know of any events happening tomorrow, so look at your email. I didn't have no commercial breaks for y'all today. But Thursday, there's events happening. You guys should go if you can. If you want to.
Brown, right?
Roscoe Brown, the library, Colston Lower Level, all of that. I'll see. May I take this down? Awesome. I think you did, yeah. You're welcome.